Hello, today we will begin with the installation of our project MedInsightsAPI, which is AI-based. The technologies we have chosen to use are Python, FastAPI with Uvicorn, NumPy, Pydantic, and Qdrant. Python is an excellent choice for those type of projects due to its rich ecosystem of libraries in the fields such as TensorFlow, PyTorch, scikit-learn, pandas, NumPy, and visualization tools like Matplotlib and Seaborn. Additionally, it offers tools like NLTK or spaCy for natural language processing. Those libraries, combined with AI frameworks, provide a comprehensive toolkit, often unmatched in-depth and usability by other programming languages. We choose to use FastAPI and Uvicorn for their high performance, built-in and excellent support for asynchronous operations, and atomic documentation generation. Very important. This feature makes it ideal for modern scalable API applications, particularly when using an API-first design approach. We use NumPy because it provides fast and efficient operations with arrays, matrices, and numerical data, significantly improving performance compared to the standard Python data structures. This makes it ideal for scientific calculations, data processing, and machine learning tasks. We select Pydantic because it provides easy validation and serialization of data through type-based model, reduces errors, and improves code readability. It is especially suited for projects using FastAPI, where it integrates naturally to handle requests and responses. We choose Qdrant because it ensures fast and efficient handling of vector databases, making it easier to implement functionality for vector search and comparison. This makes it ideal for AI projects involving RAG, Retrieval-Augmented Generation approaches. Qdrant is faster and more efficient in certain cases than the others due to optimizations for ANN, search, Approximate Nearest Neighbors, and its support for the HNSW algorithm, hierarchical navigationable small world. Additionally, it offers easy integration, scalability, and built-in support for filtering and customization, making it competitive with other vector databases like Pinnacle or Weavate. Let's proceed with the setup. First, we need to define our file architecture. In our case, it will be relatively simple. There are different file architectures such as MVC, component-based, and FSD, but for our simple demo application, we will use a simple and straightforward file structure. You can always expand and develop the application further as per your needs. Our main folder is called MedInsightsAPI. This is our project folder, and inside you can see two subfolders called API and Track. We will start working in the API folder, where will be our API file architecture. First, we have to create a file called README, where we can explain or at least describe our file architecture. That will be very simple. We need to create a folder called app, and inside it create the following files. Main. We need main for entry point of the application. It initializes the FastAPI app, defines the routes, and starts the server. Normally I will put the routes in separate file, but for this small demo application, it's fine, it's okay. Models contain the database models that define the structure of the tables or entities in the database. We need schemas to define the data validation and serialization schemas, often using Pydantic for API request and response validation. We need services to implement the business logic of the application, handling complex operations and coordinating between repositories and the other components. Repositories for handling direct database interactions, such as CRUD operations, to maintain a clean separation of concerns. Before actually the files, we need to check if you have Python installed. In my case, I do have it installed, but I don't know in your case. And yes, I have it installed. If you don't have it installed, you have to install first Python, and then we can proceed with the folder and files architecture. Our next step is to install a virtual environment. What is virtual environment? It is a built-in Python module used to create virtual environments. They isolate your Python project dependencies, libraries, and packages from the global Python installation. This ensures that each project has its own specific dependencies and versions without conflicts. After installation, we need to create the virtual environment with the following command, but before actually we do that, let's increase the size. I think it's too small to see. Now I think it's a little bit better. So our next command in order to create the virtual environment, and we have to activate that virtual environment, and this is the indicator that we have installed and activated our virtual environment. Again, I'm using Windows 11. If you're on a different operational system, you have to use different commands. You have to check it out for your operational system. I think for Macintosh and Linux this should be the command, but I'm not entirely sure. You have to check it out. Once we have VENF running, we can install the required packages for our application. The first package that we need is FastAPI, a modern fast web framework for building APIs with Python, leveraging asynchronous capabilities and type hints. Uvicorn, a lightweight fast ASGI server for running Python web applications, particularly FastAPI. Actually, I have chapters about those two. I think previous chapters, you can check it out and you can read a little bit more about them or watch my videos about them. NumPy. This is a powerful library for numerical computing in Python, providing support for arrays, matrices, and mathematical functions. Nice! Pydantic. This is a library for data validation and setting management using Python type annotations. Again, very sorry. Nice library. Qdrant. Qdrant is a client library for interacting with the Qdrant vector database. used for nearest neighbor search and similarity matching. Very nice. So, and we have everything installed, all the packages that we need. Our next step is to import base model class from Pydantic, which is used to define structured data models with validation and serialization capabilities. Validation and serialization. Then we need to import type hints list and dict from Python's typing module. Now, list represents list of floating points numbers, and dict represents a dictionary with string keys and string values. We define data model called item, inheriting from Pydantic's base model. This model represents structured data with specified field types and validation rules. We declare fields like ID, name, description, metadata that are type of strings, and metadata that is type of dict. Pydantic will validate all these fields as strings and metadata as dict. This field represents additional information about the item, and it is structured as key value pairs. Both are strings. This class is an inner class called config that provides custom configuration for the item model to allow populating fields from objects with attributes instead of just dictionaries. This is commonly used when working with ORM models or custom Python objects. This is our vector class, also inheriting from the base model, actually vector data that inherits from base model. This model represents vector data with an ID and numerical vector. The ID is type of string that represents unique identifier for the vector, and the vector field is of type of list, representing a list of floating point numbers, typically used for numerical embeddings or vector in applications like machine learning or similarity search, just like our application. And again, the inner class config. This class is unique for Python language and configures the vector data model to allow populating fields from objects. And pretty much we are done here. We are complete with the models. About this concept of inner class is actually not exactly unique for Python, but it is implemented a little bit differently from the other languages that I've worked, like PHP, Go, and JavaScript. So that's that.